Right, this is example 4 from our notes packet, 6.3 day 4 on vector applications. In this problem, we're told that an airplane flying in the direction of 50 degrees has an airspeed of 300 miles per hour. This is the vector P right here. So this vector here is P, and its magnitude is 300. Then we're also told if there were no wind, this would be the course of the plane. It would just fly 50 degrees at 300 miles per hour. However, there is a 35 mile per hour wind, and that's depicted here with the vector W. So W has a magnitude of 35, and it's at an angle of 120 degrees. The resultant effect on the plane is that it flies with a velocity that is equal to the sum of the plane's velocity without the effect of the wind plus the wind. So we can draw a new vector. Let's call that vector V, which will be the resultant of P plus W. So we'll call this vector V. And in this problem, we're supposed to find out what V is. So V is the vector P plus the vector W, and we're supposed to write this in terms of its direction angle here and its magnitude or ground speed in this application. In order to add these vectors, we're going to need to put them into either component form or the standard linear combination of standard unit vectors. Okay. In order to do that, let's first write P. We can write that in component form. So P has a magnitude of 300, and to break it into the components, we're going to take the cosine of the direction angle. That's going to give us the x component, and the sine of the direction angle is going to give us the y component. And we can see that, I'll do this just for the P vector. If I were to make a little right triangle here, I could say that cosine 50 is going to equal this length x, the adjacent side, over the hypotenuse, which is 300. So x is equal to 300 cosine 50. And likewise, I could say that if this length is y, and I want to find the vertical component of the vector P, I could say that sine of 50 degrees is equal to the opposite side, which is y, over the length of the hypotenuse, which is 300. And I could solve this for y, and I would get y is equal to 300 sine 50. So to generalize, we can always take the magnitude of the vector and then break it down into cosine of the direction angle for the x component and sine of the direction angle for the y component. So if we were to enter this into our calculators, we'd find that the vector P is equal to 192.84 miles per hour in the x direction and 229.81 miles per hour in the y direction. Let's do the same thing for the vector W. So the vector W, we're going to break that down into component form. So that's going to be, the magnitude is 35. And then we're going to take the cosine of the direction angle, which is 120 degrees. So cosine 120 degrees, and then sine of 120 degrees. And if we enter those into our calculator, we'll find that we have negative 17.5 in the x direction and 30.3 in the y direction. And that, once again, is miles per hour. So to add V, we're going to add the x components and the y components. So V is going to be equal to, if we add these up, we're going to get 192.84 minus 17.5. So 192.84 minus 17.5 in the x direction, and 229.81 plus 30.3 in the y direction. So V is going to be equal to 175.3 in the x direction and 260.81 in the y direction. That's in miles per hour. We could write that equivalently as 175.3 I plus 260.1 J miles per hour. Okay, but the problem doesn't want the vector represented in component form or as a linear combination of standard unit vectors. Instead, it wants us to find the magnitude, which is the ground speed of the vector. So I'm going to find the magnitude of the vector. I'm going to take the square root of the sum of the squares of the components. So 175.3 squared plus 260.1 squared. I'm going to punch that into my calculator, and I'll find that the magnitude is 313.7 miles per hour. And then the direction angle, I can use the inverse tangent. So I could say I would have tangent of theta is the y component, which is 260.1, over the x component of my resultant vector, 175.3, which means that theta is equal to tangent inverse of 260.1 over 175.3. Entering that into my calculator, making sure I'm in degree mode, I find out that this is 56.0 degrees.